Hello friends, I am Sharpishta Saha and today I am here to explain factors and multiples. This could be of use to school students. Actually from class 4th they are explained factors and multiples, and by the time they go to class 5 HCF, LCM and all those difficult sums are introduced. So this is a very conceptual thing and should be very clear with all students. Also those who are going to write competitive exams, this could be of much use to them also. They could also follow my videos. This is the first one I am making. Okay, now multiples. I will start with multiples. We all have learnt tables from I think class nursery or class 1. 2 ones are 2, 2 twos are 4. This is the table of 2. 2 threes are 6. What we are actually doing is we are finding out multiples of 2. Here we are actually finding multiples of 2. Multiples of any number means something multiplied to it that brings a result. So 1 is multiplied to 2 and we get 2. 2 is multiplied to get 2 and we get 4. 3 is multiplied to 2 and we get 6, like that. So 2, 4, 6, likewise 20, 50, 102. Any even number is actually a multiple of 2. Are all multiples of 2. Okay, now similarly if we try to write the tables of 9, 9 ones are 9, 9 twos are 18, 9 threes are 27, like this. Any number we multiply by 9 and we get a number that is the multiple of 9. And as we saw in case of 2, you see the multiples of 2 started from 2 itself. So 2 is a multiple of 2, then 4, 6, 8, 10, like that. And in case of 9, 9 is a multiple of 9 and then all other numbers follow. So the number itself is a multiple also. And now we come to factors. I went the other round because people tend to explain, teachers actually explain factors first and then they go to multiples, but I thought I'll do the other way around. Okay, factors is any number, take any number. Suppose I'll take a small number, 14. So if you divide 14 by 2, the result is 2 sevens are 14 and there is no remainder or it is 0. So when you divide a number by a particular number and the remainder is 0, then it is said that 14 is divisible by 2, and also 2 is a factor of 14. So when we divide a number by a number and the remainder is 0, that means this number is a factor of this number. Now we do the other way around. We take 7 and we divide 14. So what happens? 7 twos are 14 and remainder is 0. So this means 14 is divisible by 7. So 7 is a factor of 14. 7 is also a factor of 14. So we have this number 14, and we can make a factor tree actually like this. Suppose this is the number and we call this a factor tree. 2 sevens are 14, and of course 14 ones are 14. That is always there. The number itself is a factor of that number. So this I write because 14 is 2 into 7 as well as 14 is 1 into 14 or 14 into 1, the other way. Now factors of 14 are, we will list it. First of all, 1 is also a factor. 1 is a factor of every number actually. So 1 is there, then we see 2 is there, then we see 7 is there, and of course the number itself, that is 14, is there. So these 4 are the factors of the number 14. That means number 14 is divided, when divided by these numbers, the remainder is 0. That is completely divisible. Okay, now let us take a little bigger number than what we did. Suppose 144. This I am taking, this is a even number. As you know, the last number is even, then the whole number is even. So first of all, what we will do, we will divide it by 2. And why I am writing like this is, we actually do prime factorization of a number like this. So this can be called as prime factorization. That is, we are trying to find out factors, mainly prime factors. Now what are prime factors and what are factors? There is a difference. I will tell you that. First let me finish this off. So 2, 1 doesn't go, 1, 4, 14, 2 sevens are 14 and 2 twos are 4. How this is coming? I have actually divided 144 by 2. So 2 sevens are 14 and 4 came down, 2 twos are 4. So this is the result, and this I have written here. This is how we do prime factorization. Why I started with 2? Because I know this is an even number and this will be divisible by 2 already. So again I will do with 2. Otherwise, in prime factorization, if any number you see is not even, if it is odd, then you can start dividing with 3. Check it. If it goes by 3, if it goes by 7 or 5, then 11, then 13, like that. 2 3s are 6, 2 6 are 12. Again 2 1s are 2, 2 8s are 16, 2 9s are 18, 3 3s are 9. This is called prime factorization, and this is the prime factorization of 144. Now this is important because this is very useful when you are trying to find out HCF, highest common factor, of some numbers. Suppose 2 numbers, more than that. So that time you will need this prime factorization method. Now what about 144 factor tree? So first we will do this. 272s are 144. 272s are like this. 72 is again 2 into 36. We can do this way. Again, if we see 12 by 12, 104. This we can continue. 144, suppose I divide it with 12. So 12 ones are 12, 12 twos are 24. So this is a number which is a square of number 12. That is, when you multiply 12 two times, you get 144. Okay. Then this goes like this: 2 6 are 12, 2 6 are 12 again, and 2 3s are 6, 2 3s are 6. So this is the factor tree. This is one factor tree, and this is a longer one. This is another factor tree. Let's take the number 42. Okay, 42. We know 6 into 7, 6 sevens are 42. We know that very well because we have learnt our tables. Now 6, you can write it as 2 into 3. But 7 is 7 ones are 7. It is a prime number. It does not have any other factor than 1 and itself. So now we have reached, with 42 we have reached a point where we have 3 prime numbers. What are prime numbers? What are prime numbers? Prime numbers are numbers that have only two factors, that is 1 and itself. These are prime numbers. So here 2 is a prime number because it has only two factors, 2 and 1. This also a prime number. It has only two factors, 1 and 3. And 7 also has only two factors, 1 and 7. Now this is a composite number. 42 is a composite number. 42 is a composite number. What are composite numbers? Composite numbers are numbers which have more than two factors. See here, 42 has how many factors? 1, 2, 3, 4, perhaps more. 2 6 are 12 or 3 6 are 18. We'll find out, something like that. So it is a composite number. It has many factors, but 3 is a prime factor because it has only two factors, 1 and 3. Now when you have done this, when you are told what are the factors of 42, you will try to write factors of 42 are, first of all, 2, then of course 3, not with 4, not with 5, then 6, then 7, like that. And of course 42 is also there, but what are the prime factors? If someone tells you, you can write 1 also. You will actually write 1 also because factors of 42 are like this. Now suppose someone tells you what are the prime factors of 42. This is factors of 42. What are the prime factors? That means what are the prime numbers that are factors of 42? So 2, 3, 7. These are prime numbers. So 2, 3, 7 are prime factors of 42. Learned what are the factors of 42 and what are prime factors. Like there are factors that are composite numbers as well as there are factors that are prime numbers. So if someone asks what are the prime factors of any number, then you have to write only the prime numbers. You cannot write the composite numbers. Okay. So now suppose 12. Easiest number, 2 6 are 12. We saw the 3, 2 6 are 12, 2 3 are 6. Again 12 we can write as 3 4 are 12. This is a prime number, no need to write that again. So 2 2 are 4. Now what are the factors of 12? 2 3 4 6, of course 1, and 12 itself. What are the factors of 12? Factors of 12 are 1 2 3 4 6 and 12. But what are the prime factors? What are the prime factors of 12? You have to find out only the prime numbers. What are the prime numbers in this group? 2 and 3. So 2 and 3 are prime factors of 12. So in my next video I will certainly try to explain HCF and LCM in an easier way, and we will do hard sums of HCF and LCM as well, because easier sums will be explained, but hard sums they do not explain in books also sometimes. So we will do that. Thank you.